I now take up section 8.4, applications of exponentials and logarithms. Here let us say I have f of t, and f of t denotes the stock of any quantity at time t. So any quantity, that quantity can be population, that quantity can be output, any quantity, f of t denotes the stock of that quantity at time t. I know that if I think of the ratio f prime t by f of t, I know that we have done this earlier, that this is the relative rate of increase or the proportional rate of increase of that stock at time t. And in many cases we see that this relative rate of increase or the proportional rate of increase, it is constant. That means it is equal to r. Okay, if it is a constant r, that means if the relative rate of increase of that stock at time t is this constant r, or if the proportional rate of increase of this stock at the time t is r, in that case I can write f prime t equal to r f of t for all t. For all t. Now the question is, which are the functions that have a constant relative rate of increase? Which are those kinds of functions? We are going to see that if I have a function of this type, f of t equal to a e raised to the power rt, these are the kinds of functions that are characterized by a constant proportional rate of increase. These are characterized by a constant relative rate of increase. Why do I say this? Because in this case, if I go for f prime t is equal to a e raised to the power rt multiplied by r. That means it is r a e raised to the power rt, and that means it is equal to r f of t. So even here I see that f prime t by f of t, which is the relative rate of increase of the stock at time t, I know that this is equal to the constant r. So I can see that functions of this type are characterized by a constant relative rate of increase. The point to understand here is that only functions of this type, only these functions have this kind of a property. That means you don't have any other function having this property. You don't have any other function, any function other than a e raised to the power rt having this property of a constant relative rate of increase. To prove that, let us suppose we have g as a function. So you have g is any function, I suppose. Just what I'm doing here is that I'm proving that only functions of this type have this property. So to prove that, we are supposing g is any function satisfying g prime t is equal to r g of t. So this is also another function, let us say, which is satisfying this property, of having a constant relative rate of increase. Again, here I should write for all t. In this case, I define a new function h by h of t is equal to g of t e raised to the power minus rt. Now if I define this new function h by this, in this case if I go for h prime t, I can actually apply the product rule, and then I will have g of t e raised to the power minus rt multiplied by minus r plus e raised to the power minus rt multiplied by g prime t. This can then be written as, I can write h prime t is equal to e raised to the power minus rt. I can just take that out and I will have minus r g of t minus r g of t plus g prime t. And if you can see this, I can now write this as e raised to the power minus rt g prime t minus r g of t. Now I know that I have actually supposed g to be this function which satisfies g prime t to be equal to r g of t. That means if I go for g prime t equal to r g of t, h prime t is actually going to be 0 for all t. And that just means h of t is some constant a. It is some constant a. So that means, given this, I can now see what I can write about g of t. G of t is equal to h of t multiplied by e raised to the power rt. H of t e raised to the power rt, and we know that h of t is equal to a. That means this is the case. So that actually proves that only this function, which function? A function of the type a e raised to the power rt, only this function has this property of a constant relative rate of increase, not any other function. So we have proved here that, so we actually started out with g to be any function satisfying this property of having a constant relative rate of increase, and we saw that g is a function of the same type as f, which is a e raised to the power rt. So we have now proved that only functions of this type have this property, and that means we can now write f prime t is equal to r f of t for all t if and only if f of t is equal to a e raised to the power rt for a constant a. And we are now going to consider some applications where this is important. This particular fact is important, that if you have a function characterized by a constant relative rate of increase, that function is going to have this type, which is a e raised to the power rt.